we go. You guys ready? Today is the best day ever. This is.
Can we get donuts?
No, there are no donuts or candy or anything that you all can consume involved. But no, there's homework. But it is the best day ever because we are doing a method of factoring that is the best factoring ever. So. I know that is just too much for you all to handle. I know I did. That's okay. I don't mind that. All right. So, here we go. We are going to factor. This is actually one of the most common types of factoring. And we so far have learned difference of two squares, perfect square trinomials, and some very specific types of factoring problems. But there are so many types of factoring problems out there that do not have specifics assigned to them. So we need a method where we can factor that will work all the time for these, and that's what's called the diamond method. So bear with me here. What's that? Okay. So we're gonna do this using an example problem. If we try and do it just by like a general one, it's going to be way too confusing. So here's the way we're going to do this. I'll tell you, fourth period last year, loved this. Loved it, loved it, loved it. Why? Because it's super easy and it works for all types of polynomials. Okay, so here we go. We're going to label our coefficients. Whatever's in front of x squared is a, whatever's in front of x is b, whatever does not have any variable attached to it is c. So that, you guys learned a while ago. Oh, for the love. I am awake today, I promise. You learned a while ago the quadratic formula. Remember? Negative b plus or minus. Song, yes. Okay. So, these are the variables that are the coefficients that go with that song. So, here's how this works. We're going to take a and c and multiply them together and put them in the top of this. It says it's diamond method. It's diamond because there's actually a diamond drawn around it, but it takes too much time to do that, so we're just drawing the x part. All right, so what's in front of the x squared? What's in front of the x squared? 1. What's 1 times negative 21? Negative 21. Okay, in the bottom goes b, whatever the b coefficient is. So, what's our b coefficient? 4. So in these two sides, we are looking for two numbers that multiply to get negative 21 that also add up to get positive 4. So can anybody think of two numbers that multiply to negative 21 and add to positive 4? Taylor, go ahead.
7.
Excellent. Everybody give it up for Taylor. All right, now, the next thing that we're going to do is we're going to take this x squared, and the invisible 1 in front of it, and we're going to evenly distribute it to both of these terms, okay? So if there are two of them, that means 1 goes on top of the 7 and 1 goes on top of the 3. You're going to make little fractions out of them. Fractions aren't really all that significant right now, but they will be when we start having numbers other than 1 in front of the x squared. So that's where everybody starts hating life. Okay, so here we go. If we can't reduce, those are our two factors. X, it's a positive 7, so x plus 7, and then the other one is x and negative 3, so x minus 3. So that is the factored version of x squared plus 4x minus 21. Yes, we're going to do more complicated ones. Questions? We are just getting practice with this over and over and over again today. Questions? Can I take this away? All right, so let's say we've got, whoops, let's do this. Example factor. All right, negative 8x plus x squared minus 20. Negative 8x plus x squared minus 20. Okay, so what is the first thing that we need to do with this before we can start filling in our x? Ashley, R? Good. Everybody give it up for Ashley. We always want to make sure we put the squared, or in descending order. Okay, so then if we have our coefficients, you do not have to worry about labeling these. As long as you know A, B, and C, you're good. Draw an X. Okay, so can someone tell me what goes in the top? We can go through this probably really fast from this point on. Akashni. -20. All right, everybody give it up for Akashni. And what goes in the bottom? Lydia. -8. So we're looking for two numbers here that multiply to -20 and add up to -8. So everybody be thinking in your head, two numbers that multiply to -20. And then can we finagle any of them to add up to -8 at the same time? Sonia.
-10 and 2.
Everybody give it up for Sonia. Hey, what do we do next? Put the X over them. We evenly distribute that X squared, so each side gets one of them. And then what is the last step? Stacy? Uh-huh. All right, everybody give it up for Stacy. All right. What's up, Lydia? Okay, so this is a method that we use to get to the final answer. The fraction part comes in handy with what we're about to do. Sometimes you'll end up having to reduce these, so you're like weeding out any excess numbers or factors. That's the whole point of setting them up like that. It's just a step means to an end. Questions? Other questions? Okay, so let's do one of those next. Let's do one that has something other than 1 in for a coefficient. Because if we think back to Algebra 1, I'm just saying, Mrs. Barnett and I, we talk a lot, and I used to teach Algebra 1 as well. That's when everybody starts hating life, is when we start having numbers other than 1 in for those coefficients like this. 2x squared plus 9x minus 18. 2x squared plus 9x minus 18. Lydia. What do you mean what happens to it? So basically what's happening here, let's go back to this example. What we're essentially saying when we factor an expression is that this this expression divided up or factored out is equivalent to this one. So if we were to FOIL this out, when we multiply the -10 times the x and the +2 times the x and combine them, we would get the -8x. Does that make sense? All right, Stacy, what's up? You don't. You don't. This only works for trinomials. Oh, okay. You can use it for all trinomials. Like, is that what I said? No. Oh, all polynomials. Oh, then I misspoke. It's trinomials or binomials that are quadratics. Sorry. Didn't mean to deflate you all, or inflate you and then deflate you after that. Okay, so here we go. We have our A, we have our B. It's already in descending order, so all we have to do is label and then draw our X. So who can tell me what goes in the top of this one? Elizabeth. Good. Why is it -36 and not just -18? Cool. Everybody give it up for Elizabeth. So the top, remember, is A times C. 2 times -18, -36. Bottom is, everybody shout it out? 9. So we are looking for two numbers that multiply to -36 and add up to +9. Maybe think of those. Jared? No? Okay. Michael?
12 and -3.
Cool. 12 and -3. So, yes, give it up for Michael. Thank you. Okay. So before, just bear with me here. Before, what we did was we brought the x squared down and we distributed it evenly, correct? Yes. But now we want to include this same, whatever the coefficient is, we want to include that on both of them. Okay, that's the funky part, is because there's only one of those coefficients, why do you bring it down twice? But you guys tell me what happens. If we look at these fractions, can either of them be reduced? Kendra? X over 6. Give it up for Kendra. Thank you. Now, are both of these reduced as much as they possibly can be?
Yes.
So that's one factor, that's another. X plus 6, what? You do if you can. This is why, so remember when we multiply this out, this should equal what's up top. So x times 2x, 2x squared. 6 times negative 3, negative 18, and then combine the things. Questions? Is it pretty easy? Yay! Ashley.
Okay, so if it happened to say 2x to the 4th,
Yes.
you would have 2x squared.
Exactly. You're basically evenly distributing however many of the variable you have. So if it was like x to the 50th, let's say that. X to the 50th here, what would each side get? 25. Now, what if it said something like, let's just play with this for a second. What if it said 2x squared plus 9xy minus 18y squared? So then, just if we distribute this x squared evenly to the top, can anybody take a guess at what happens to the y squared? It also should be evenly distributed somewhere within these. What do you think, Jared?
The bottom.
The bottom of the fractions, yeah. So then at the end, you'd have a y on the end. Does that make sense?
Is that going to be in our homework?
It might be, yeah. I can't remember. If you guys want to go through a specific example like that, we can do it. Everybody get out the book and look at the homework problems, and let's pick one and we can go through it for notes. What's up, Jared?
What if there are more than 2 variables?
If we're dealing with this type of problem, yeah, you're still going to do it the same way. I'm trying to think in my head, like, what an example would be.
I mean, you said it went through all trinomials. What if we had like 2x squared plus 5a plus 18y? Like, what would be that?
Okay, so in that case, there are some that are going to be not factorable.
So it doesn't work for all.
Okay, yeah, so
It works for all trinomials that can't be foiled.
exactly. It works for all trinomials that can be foiled, that can be factored. Yes. But there are some, yeah, exactly. There's some that are not factorable, and so that's, yeah. All right. Can you guys pick one out from the homework that you want to go through up here? Which one? Okay, read it off to me.
Negative 2a minus 63 plus a squared.
Okay. Say it again.
Negative 2a minus 63
Uh-huh.
plus a squared.
Okay. Negative 2a minus 63 plus plus a squared. Okay. First thing that we have to do here, Kendra.
Rewrite it.
Rewrite it how?
To the squares and a.
Cool. Everybody give it up for Kendra. Okay, who can tell me what goes in the top? Akashni.
Negative.
And the bottom?
Negative.
Okay, so two numbers that multiply to negative 63 and add up to Marcy.
Negative 9 and 7.
Cool. Everybody give it up for Akashni and Marcy.
Yay.
Okay, and what is the second to last step? Second to last step?
You bring down those a.
Good. Distribute the A's to each of these, and if they can't be reduced, which they can't, those are your two factors, 8 plus 7. Questions?
Can we do number 27?
Sure. Okay, is there are no questions on this one? And then
Is it even?
pick one. Doesn't matter. 27. What is the homework again? Oh, 2 to 30 even. Oh.
Okay, never mind.
So somebody pick. No, we're gonna do one more. 30? Okay, read it off to me.
6x to the 6th.
Okay,
X to the 3rd
minus 12. Okay. So 6x to the 6th plus x cubed minus 12. It's already in descending order. So what? This is number 30 on the homework, you said? Okay. So in the top, what goes in the top of this? 72. The bottom? 1. Two numbers that multiply to negative 72 and add up to positive 1. It exists. I'm thinking of them right now.
Yeah.
Nick?
I got it.
Excellent. Everybody give it up for Nick. Okay. So then what do we do next?
You bring down the x.
Good. And you have to bring that 6 with it. Now, we have an x to the 6th power. If we want to evenly distribute those 6, how many go on each of these? 3 and 3. So x cubed, but again, you want to bring that 6 down for both of them so that you can reduce any fractions. So that's how you take that into account. 6 and 9 reduce to what?
1 over 3. No.
Not not 1 over 3. That's 2 over 3. 2x cubed over 3. Is that reduced as much as it's going to be?
Yeah.
Okay, so we can circle it. How about this one? 6 and negative 8. 3x cubed over negative 4. That's reduced. So what is this factored completely? So what's our final answer here? Yep. Excellent. Now, what's the way that you can check that you did it right again? If you FOIL it out, you should end up with what's in the top. A quick check, a quick check would be to multiply the first and the last and see if you get the first and the last terms. So 2x cubed times 3x cubed, does that give us 6x to the 6th? And does 3 times negative 4 give us negative 12? Yes. All right. I'm going to leave you guys to work on this for the rest of the period. I think we all can get extra credit today. Yep. So let me go ahead and write the assignment up here. It's homework 31, page 203, 2 to 30 even. Okay. All right. Everybody go ahead and get going if you haven't already on the homework.